So welcome back. For me, it's always a pleasure to work and help anybody. So we are Leonardo and Gracila. We both are from UFMG here in Belo Horizonte, in Brazil. My focus on my studies are digital methods. Whoops. My focus is on digital methods and methodological protocols for online investigation. We're both members of REST, which is a group in communication studies here in Brazil focused on social technical networks. I think for me, that's it. You go now, Gracila.
Yeah, so I'm Gracila. I am a PhD researcher in contemporary communications and sociability at the Federal University of Minas Gerais, as Leo said. My current research focuses on the Brazilian nanosphere. I'm also a researcher at RES. I've been working with feminist theories and gender studies with an intersectional approach and media and platform studies since graduation, and that combination was central to my master's thesis. So now I think you all got the link. We're going to explore the presentation through the lab. So now I'm moving to the description and really quick to the description and requirements. Our major...
I think at this point, maybe everybody has GIF installed, right? At this point.
Yeah.
And you do have Word IJ as well, I hope so. Does anybody have any trouble with it? If not, let's just move straight to the practical lab overview.
Okay. So if you, well, at any time, if you have any questions, please talk to us in the chat or interrupt us. We are happy to help. And just a short description, we are going to use Word IJ to process linkage between words, and we'll focus on the network output from Word IJ based on co-word occurrences. And then we go into to Gephi with that output. Empirically, we investigate gender gap issues related to the ambivalent movement, Women in Technology. The movement is both academic and labor market relevant and exposes tensions on diversity, inclusion, and social ranking. Our focus on the movement is academic, seen through intersectional lenses. So I'm just gonna give you an overview of the practical lab. We divided the practical lab into main segments. The first one is building the database, and the second one is data analysis. Each of the segments have three different tasks, and we're going to go through one by one. And now we're going to start building our database. Because our methodology works with networks of words, we chose Wikipedia due to its verbal-centric quality. Where our point is not to look for the truth about the movement, Women in Technology, but to realize how knowledge is being built around it. As a collaborative and collective technology proposal, we approach Wikipedia as a source of open textual data. So if we click, we queried Women in Technology on Wikipedia, sorting by relevance. So if you click here on the database, Women in Technology, we're going to go straight to our query. And here you see that we chose to sort by relevance. So the first one, the namesake, Women in Technology, was a compilation of other articles. And the next result is a music album, so it wasn't good for us. And the third one was Women in Stanfield, which points to too many places and gave us a huge database that we couldn't work in 1 hour here with you guys. So we chose Women in computing as a starting point for this practical lab, because it's not too wide or too narrow, and it translates pretty well the idea of women in technology. So here is the article, and I'm going to ask you to focus. See, it's a big article, and by the end of the article, we have this see also section. I'm going to go back to the presentation real quick. So this is just a print for the query. And if you click here, you also have the Women in Computing article that is also open here. Then moving to the next slide, we went to CISology that was designed by Density Design Lab in Milan. And I'm going to open CISology here.
They were here just right now. I'm so sorry that I couldn't congratulate them in person. This is a really useful tool, useful tool to explore Wikipedia articles.
Yeah, so I'm just going to copy the link and paste it here. And here we have distance, which is like one distance is the directly link articles in the C also part of in Women in Computing. And the two distances like the C also articles from the directly related articles on this one that we are working with. So I'm going to choose one, and then I'm going to start crawling. And here we have, it was choose two. Oops, sorry. Yeah. So here we have the network of DC also articles related to women in computing, and below is a list of the articles that are related to the one that we chose. As we wanted verbal-centric articles and not lists or timelines, we did not include this article on our database. So as you see here, we have cut this one, and we have 8 articles to work with from now on. Is that okay? So if you click here on the presentation, we have linked our database of selected articles here. So you have the link directly. So just going back to the presentation really quick. Sorry. I think my computer is a little bit slow. Yeah. So then we opened Text Reaper, which was developed by DMI from in UVA to extract the text from the links of our database. So we open Text Reaper. And then we will copy, sorry, the menu is coming down here a little bit, so I'm having trouble, but I'm going to access the database again here. We're just going to copy the links here. And then we're going to go to Text Reaper and paste them there. And then we're going to read texts. What we got here is a link that gives us a full assemblage of articles, and that is our text output. So if you click here, you have the text output. Is that okay? The way that we built the database? If you have any questions. So I think we can move forward. And if you click here and on the presentation as well, you're going to see the text output. Okay, the same one that I just showed you. I think, Leo, the floor is yours, I guess.
But that's it. I mean, did everybody got the idea that we came from 10 articles in Wikipedia and drove them into an HTML file composed only by words?
Yeah.
Those are only words. Then we can just, um, before entering the computational aspect yet, let me just take 2 steps back and come to what is WordIJ. WordIJ is a software in .jar format, and it pairs words within a configuration, in statistical configuration. What does it mean? Let's take, for example, this quote from William Shakespeare. A fool thinks himself to be wise, but a wise man knows himself to be a fool. We chose this because, first of all, Shakespeare, and then because there is repetition of words. If in this situation we are going to input this sentence in WordIJ to build the pair, what happens with the word knows? If we take a 3-word window size, knows is going to pair with but, wise, and man, and also to the right side with himself and fool. Why not the word A to B A? Because those are words that we drop out before the count, before the assemblage of the word pair. We're going to see this in practice right now. But then again, you see the linkage, the strength between the links within the words are always the same. You see, this is really important. Next step, please. This is the WordIJ interface. We are optimizing it for the, actually this practical lab is focusing only on the word link module. That's we are going to operate. WordIJ is a really big software in linguistic analytics and for other purposes. But then we are here to do platform analysis. So um, first of all, we have those yellow arrows, which are really important to pay attention. And we have these black arrows, which also are important, but then not points of big discussion. The first text file we need to build is the input of the words that we are going to use. We're going to take that HTML. Gracila, could you open that again, the full HTML file with all the words?
Let me just try because whenever I hit, yeah, here. This one?
This one. You can just select all. Control A, Command A, Control T, Command T, I don't know, whatever. And you have to save this file in a format that doesn't codify the characters. What does it mean? It has to be in UTF-8, codification of characters. In other words, you can just save it on a notepad or in a text editor on Mac, but the file should be saved as a .txt file. After you've done it, you have the first input you need. Then come back to the presentation, please. The second file we need to input is the drop list file. What is that? This is the words that are not going to be counted within the word pair building. Remember the William Shakespeare example? Prepositions, numbers, dots, commas, punctuation, all of those characters that we don't want, and also some words that we don't want to occur in the word pair formation. We always must select the output in pajek format. That's a network file in the back in the 90s. I don't know if anyone's still using pajek. And then we come to the point 4, 5, 6, and 7. Those are going to be the configuration of the pair that we want to build. The number 4 is going to drop words before the software run the calculations. We are going to drop words that don't occur at least 3 times. We can always configure it to make it higher or smaller. But then again, we are using the default configuration. At each case, you should specify your and take notes so you can be able to justify methodological approach. Then, the point 5, we are going to drop pairs that do not occur more than 3 times. If you want a bigger network, this number should be smaller. If you want a smaller network, this number should be bigger. All right? It's very simple logic right here. At number 6, things get a little bit complicated. At least I have always worked with the constant force strength between words. Why is that? Because me and Gracila are trying to see the network outcome of it. We are not trying to make a word that occurs more than 1 time, a pair that happens 4 times, bigger in the network than the other one that only occurs 1 time. We are trying to see the whole semantic network that is going to be presented to us. All right? So we use the constant strength linkage method. Okay? And the most important of all, what is going to be the window size for the pair formation? If you want to have a bigger network, this number should be higher. All right? So that's it. That's the word link module on WordRJ in a theoretical approach. Let's do it empirically right now.
So I'm going to stop sharing my screen and you're going to start sharing yours, right?
Yeah.
Okay.
Let me just close some of the... Hope you're all seeing my screen, right?
Yes.
First of all, you open WordRJ. It is a Java format. Make sure it's on the word link module. And you have to build a folder with the 2 inputs. Those folders are linked in the I just send it on the chat. You can always download both inputs. You see? After you're done downloading them, you should keep them in the same folder. The first one is the database we built from Wikipedia called Women in Computing. Oops. Remember, saved as txt file. And then I downloaded from a linguistics website a simple stop word list in English. But then again, we are using Wikipedia. This means we are going to have some interface words that happens on Wikipedia occurring a lot. You see, all those words are going to be dropped before the calculation. Also, we selected navigation and jump. Both are words that occurs a lot in these articles of Wikipedia, and we don't want them to pollute our network. We also placed women. Curiously, we're studying women in computing. But although we have to remove the word women, because when it comes to the network visualization, women become so centralized, so big, that we can't explore the network in a way that is supposed to, in a way that facilitates our perception. Okay? All right, so browse, browse, desktop. Inputs. First one, you choose the database. Second one is the drop list file or stop words. You must always select output in pajek, drop words appearing less often than 3 times, pairs appearing less often than 3 times, constant strength, window size, analyze now. The outputs are going to be presented in this little window. You see, it took, I don't know how is that in seconds, but that's really fast processing text file. And the outputs, all of the outputs come right here to the folder that we were using with the inputs. So I'm just gonna put another folder right here, the outputs.
Is everyone with us so far? Yeah?
So far, so good?
Yes.
With me, it says there was a problem during execution. Pretty much.
What is the problem?
So I click analyze.
Have you created a single folder with the input file?
Yes.
That's odd. Maybe close Word.ij and run it again.
Okay.
When it comes to the outputs, Danielle, please let me know if it does not work the next time. When it comes to the outputs, remember that Word.ij is a linguistics software. So we do have lots of statistical approaches in this word pair calculation. One of them are these tables. That I don't know if this doesn't scare you at all. I don't know, you should be a mathematician or a statistician. But then again, you can see the frequency of the pair, the entropy of the pair, the proportion of pair occurrences, which for us at this point, it doesn't really matter. What we are looking for in the outputs file is this .net file, which we are going to open in Gephi. Has it worked, Daniel? Meanwhile, Gephi is opening.
No, unfortunately not. But I'm gonna just follow from here on, I guess.
If you don't mind, you can always share your screen and we can take a look.
Yeah.
All right, so I'm gonna stop mine. Go ahead.
So
So I'm here and I browse and I'm at Women in Computing.
Mm-hmm.
And I click Analyze Now. Yeah.
And probably you got the wrong WordIJ installed.
Yeah.
You see, you have to download the 64-bit version for Windows.
All right.
I don't know. I'm taking a hint. I'm taking a guess.
Yeah, I thought I had this one. Oh, yeah.
Let me see the folder. Let me see the folder you've built.
Inputs, pretty much.
And the stop words come as well from this same folder.
Yeah, it's this one.
All right, that's strange. But as I said, WordIJ is a file. It's an executable program in .jar format. It doesn't have a lot of problems, and it's really light. For me, I think you should reinstall it as a 64-bit Windows version. I don't know. I hope it helps.
All right, thanks.
Coming back to our Gephi. You're just gonna open the network where you just save it, that .NET file. Here we have the import report. These are mixed typography. We're going to have words linked. There are pairs both ways or not. We have 2916 nodes, 2938. That's a fair amount for us at this practical lab. We're still using Force Atlas 2 layout algorithm to display the words because we are trying to get a relational position of the words and not a geometrical one. And this is it. After that, we can always, those who were there this morning, remembers how we work with the labels. Just gonna put them in little red. Fonts to be. So this is it. These are the word pair network visualization. We still haven't yet worked within the visualization. So that's when I'm stopping you all and asking, do you want to go back to WordIJ, or can we go and explore this network within the issue network called Women in Computing? If nobody gives an answer, I'm just gonna keep on crawling the word pairs and navigating through them. What helps a lot at this point is calculation of modularity, so we can have subgroup formation inside these pairs. I'm working with the resolution 1.0 just to experience what's going to happen. From the colors, the aesthetics of the network, the color, I'm going to choose modularity class in the partition section. We have at least 1,000 clusters in this network, in this single network. So this is not something easy to explore. Actually, the opposite. For me, as more as I talk and teach and learn about Gephi, the harder it can get, because the technical mediations involved in each step we are taking here are really serious to the results and the methodological choices we're making. After that, we can come to prevent overlap, so we can see the pairs. And in this size section, I'm going to choose ranking for degree, for example, which is a calculation done by Gephi. It's not built upon our database from WordIJ. This is a calculation made by Gephi. Then we apply, and we do have this network. Just gonna. So this is it. Gender, science, female. What happens here is we have these big arrows, these big pointy arrows from the word retrieved, for example, to another word, January. This is a word pair. The edge in the Gephi right here is the mathematical representation of the word pair we just made, and the nodes are the words. What we do here, and I would like for us to come to the presentation back again. Is that I've done it real quickly. We can always go back, but I've specialized the network. I colorized the network. I worked with the size as well in the degree, and I done the modularity calculus. So we can have subgroups to explore. After that, that's when our work really begins. That's when the qualitative research begins. Because until then, the machinery was doing all the work for us. Gracila,
Yeah.
do you want to?
Just wanted to highlight on the slide before that this same network we have on our database. If you click on file, you get the same image that we're seeing here. Now maybe I have this one open here in my computer. Maybe I can show on Gephi.
I'm just going to stop sharing my screen.
Okay, so. So do you see the network? Do you see my screen?
Yeah.
Yeah. So this is the same network that you can download on that 10th slide. It's linked there. So what do we have here? We have this peripheral area with words that support and complement the topics of interest, but do not directly compose them. Here we have 9 clusters, 9 major clusters, sort by color regarding women in computing. So I'm going to go through them a little bit. We have 5 diffuse things. We have gray and green here. And here we have gray and green, which relates to countries, ethnicities, and belief systems. See, Malaysia, Lebanon. And then we have this light pink here, which are words like tools and assets and resources relating to women in computing. Then we have this orange one that It's a little bit about fields of work and ideas about media, and media here centered on video games, countries, interactives. Then we have this pink one here, that it's majorly related to the history of women in computing in the United States. Then we have 4 concentrated things. We have this blue one that is about female participation in different fields of work. We have this purple one that is majorly related to gaps regarding gender, and we have this black one that is majorly related to engineering and opportunities for women. And we have this light green one that is about concerns about participation in science. And then we have different types of science and history and linked here. So from that, we can go to a quality approach, which I was going to explain really quick.
Yeah. So then again, we are not becoming, in the sense of platformization, which is the main point of this event, we are not becoming slaves to the technicity of GFE, to the technicity of WordIJ. We're always putting them in tension. That means each cluster that Gracila has just explained for us, just a little sample of these clusters, each one of them, it's going to compose what we are calling a bigger topic of interest.
Yeah.
That doesn't mean the whole nodes in orange, for example, consists in one topic. What it means actually is, come back again to the black cluster again, Gracila. Women in engineering, really similar to the as you can see on the slide 10, the opportunities relating to engineering. This is one topic of interest related to this big issue that we are calling women related to STEM. You see, I hope you all have done it in your own computer. And if not, I think you don't have many questions for us at this point of the day. And if the technological procedures are done, do you have any questions? So for me, what do you think, Gracila? For me, I think we're done here. Nobody has any questions, and we covered the.
Yeah, and if anyone wants to talk to us about anything at all about this, or maybe some more theoretical approach, or maybe some more methodological approach about this, please. Our emails are on the slides. Yes, Fabrice, I think the interpretation is maybe the hardest work, and I think that's our point here.